Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department, SNS College of Technology, and Autonomous Institution, Coimbatore. Based on my previous video, you may have some basic knowledge about what is meant by a microprocessor, how the internal architecture are constructed, and what are the various addressing modes that are used in 8086 microprocessor, and some of the instruction sets, and also some of the assembly language programs are discussed in my previous YouTube playlist. Now, I am going to discuss the interfacing requirements of 8086 with some other external components. For example, the output of 8086 can be viewed in a LED display or some LCD display or some buzzer motor or some alarm system. So many output devices are there. So here I am going to discuss what are the basic interfacing requirements of memory mapped input IO with IO mapped IO. IO means input output devices, and how these input output devices are linked with memory that are going to be discussed here. So there are two types of data transfers are available. One is called the synchronous data transfer and another one is called the asynchronous data transfer. Synchronous means usually it occurs when peripherals are located within the same computer as the CPU. Closely proximity allows all state bits change at same time on a common clock. Asynchronous means it do not require the source and destination use the same system clock. Next one, this figure shows the memory and input output interfacing. If you see this figure, all the memory are linked with either an address bus or something the data bus. Also, the memory write transmission control, the memory read data control, input output word control, input output read control. ROM and RAM are linked with the data bus, and a keyboard are linked with the address bus and data bus. Also the printer, that is the output devices, are linked with the address bus and data bus. So based on this diagram, we can understand that address bus are controlled with all the areas and the data buses are limited with the only some input and particular element of output. Interface memory, that is the RAM, ROM, EEPROM, are input-output devices to 8086 microprocessor. Several memory chips or output devices can connected to a microprocessor. An address decoding circuit is used to select the required input-output device or a memory chip. Input-output versus memory mapped input-output, that is the difference. Here memory mapped IO is a IO treated as a memory. It is a 16-bit addressing. More decoder hardwares are available and it can address up to 64 kilobyte of location. Less memory is available. Whereas if you take IO mapped IO, IO is treated as IO. Here it is a 8-bit addressing, less decoder hardware, and it can program output to 256 only, and it is the whole memory address space is available. And also the memory mapped IO will do for memory instructions are used, memory control signals are used, arithmetic and logic operations can be performed on data transfer between register and IO. Whereas in IO mapped IO, special instructions are used like in and out. Special control signals are also used. Arithmetic and logic operation cannot be performed on data transfer between accumulator and input output memory. So in this video, I discussed what are the various requirements of input output memory and how these are interlinked with the data bus and address bus, and also I have take the comparison between input and output memory. In general, the input devices of 8086 are the keyboard or some of the signals, that is analog to digital converter, or some of the sensors are considered as the input devices. Sometimes the output devices may be a printer or a floppy disk, or sometimes a LED display, or sometimes a LED display, or sometimes a liquid crystal display, also the DC motor interfaces. Anything that can be taken as output of 8086 are called output element. In basically, the 8086 are interfaced with 8259, 8279, 8255, that is the programmable peripheral interfaces. Also, in old generation, this microprocessor main application is to do the application of arithmetic and logical operation. Normally, arithmetic operation means addition, subtraction, multiplication, division, and For logical operation means and or not nor, and XOR operation also. So because of this, we can do so many mathematical and logical operations in a minimum short period of time. That is the main advantages of 8086. Later on, the smaller size of 8086 cannot be used in large, so we can go for 8051. So at the next YouTube playlist video, I am going to discuss fully about what is in by 8051, how it varies from 8086, and what are the various addressing mode instruction set that are available in 8051, and how this 8051 is interfaced with the output components. All this I am going to discuss on the next video. So thank you for watching this video. Thank you.